In this last section of Chapter 5, we are looking at non-decimal systems. And the reason we are going to consider these base 5 and base 6 notation systems is to give you an idea of the discomfort that some of our students are going to feel when we're first introducing our base 10 system. We can take it for granted that we have the ones place and the tens place and the hundreds place and so on. But sometimes it can be very overwhelming for our students. And so we go through these systems so you can maybe go back to that mindset of it being a little bit uncomfortable. So if this section feels a bit uncomfortable, it's supposed to. It's not supposed to be completely overwhelming for you, but it's supposed to feel just a little bit uncomfortable. So we're going to look at base 5 and base 6 systems. I'm going to spend a little bit more time with the base 5 systems in the examples. And by the way, I am only going to go through a couple examples on video. The other ones I've got pictures and longer explanations. If you would like me to go over in a video form any of the examples, any of the other examples in this section, please, please, please send me an email and I will gladly do that for you. It is not a problem. But I'm only going to go through the couple examples, maybe the 3 or 4 examples in here where there's things to fill in. So I just want to give you that heads up. So I have the first few positions in both the base 5 and the base 6 system. So you have what we call the units or the ones place, okay? So that's represented by the base to the 0 power. That's our ones place. Now think about our base 10. We go ones, then we go the tens. When we're in base 5, that next position is the 5's place or the 6's place. Then moving up in our base 10, the next one will be the hundreds place. Okay, that's 10 to the 2nd power. Here we have 5 to the 2nd power, which is 25, or 6 to the 2nd power, which is 36, and then it continues up. So I'm going to go through a couple examples here. The first one, we have a base 5 representation of a number, and I'm going to write it in our more familiar base 10 system. So we want to pay attention to our place values. We have the ones place, which has a 4 in it, the 5's place, which has a 1, the 25's place, which has a 2, and then the 125's place, which has a 3. So we do not read this as 3,214. This is 3214 base 5. So again, this means 3 times 125 plus 2 times 25 plus 1 times 5 plus 4 times 1. So again, to think of our place values. The ones place, the 5's place, the 25's place, and then the 125's place. These are just powers of 5. So that gives us 375. Again, now we're in base 10s, plus 50, plus 5, plus 4. So in base 10 numeration, we have 375 plus 50 plus 5 plus 4, which is 434. Because base 10 is our standard base, we don't write a 10 down here. When you see a number written like the 434, think base 10. If it's a different base, it will be explicitly labeled. Now, we're going to go backwards for the second example. Here we're given the base 10 number 97, and I'm going to show you how it's written in terms of base 5. So we have 97 beans, and if you were doing this in, let's say, a classroom with gifted students, you could have your little bean counters. Since we're in a base 5 system, started out by putting them in groups of 5. So you can see the green circles represent a group of 5. So we have all of these groups of 5, and then there's 2 left over. So those are our ones place, if you will. Now, with the base 5 system, we have the ones place, the 5s place, and then there's the 25s place. So the 25s place are 5 5s. So here in the red circle, I have one group of 5 5s, a second group of 5 5s, and a third group of 5 5s. So in my 25s place, I have 3 25s. Then I have 4 groups of 5s. And I have 2 ones or 2 units. So I have 3 4 2 base 5. So in our base 10 representation, 97 would be 3 4 2 base 5. It's the same amount of beans, just 2 different representation systems.